Okay, so now we're going to talk about something called anti-differentiation, which actually is called integration, but it's quite a good way to introduce the topic. So, what I have here is I have a differentiation box and I have an anti-differentiation box. And what we're going to do is take these functions, f of x's, and differentiate them, and they're going to see what happens. Oh, skipping ahead. I'm going to see what happens when we... I might just start this again. Come on then. Okay, so now we're going to talk about anti-differentiation, which is code for something else, which you might have guessed. But anyway, you can be thought of as just the opposite process of differentiation. So what I have here is I have a differentiation box and I have an anti-differentiation box. And what we're going to do is pass through some functions and differentiate them. So here we've got f of x is equal to negative 5x, 4 to the x to the power 4, and x to the power 2 or 3. And when we differentiate them, we get these values here, minus 5 to the power of negative 6, 4 to the 3, blah, 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 blah. Cool, right? So that's fine. Bread and butter. We've done this before. But what would happen if I said, okay, I want you to anti-differentiate these? Right, okay. Well, you can notice you're just going to get back your original function, right? You're just going to get back whatever you had before. You can see that this anti-differentiation is just the opposite process. It's just whatever you did from here to here, undo it. Go from there to there, right? It's just the opposite process. So let's do an example. So here, it says find the antiderivative. Let's get my red pen. So here, so this is f dash x. I want f of x. Okay. Now usually, okay, when I'm differentiating, what would I do? I said I'd times by that power and decrease the power. But instead, okay, I want to do the opposite way. So what I'd have to do first is I'd have to increase the power, then divide by that power. Okay, so that gives me x to the power 7. What about this one here? So f of x is equal to, well, that was negative 14x. So let's write that in, negative 14x. Okay, so what, right, I would have times by the power, decrease the power. So I want to increase the power by 1. So that's going to give that as negative 14. Then I want to divide by that same power, negative 14. So that actually cancels, and I'm left with x to the power of negative 14. Cool. Last one. I have, oh, that was g, my apologies. That should be g of x. So last one. What's t of x going to be equal to? Okay, so I'm still going to have the negative 1 over 2. But this x here is going to be 1 bigger. So you're going to have this negative 3 over 2 plus 1, which would be basically 2 over 2, all over this negative 3 over 2 plus 2 over 2. I'm just showing all the steps here because it's a fraction to make it a little bit easier. Okay, so what's this going to equal out to? Well, negative 3 over 2 becomes negative 1 over 2, okay? So this becomes negative 1 over 2, so they cancel. So you're just left with x to the power of negative 1 over 2, or you can write it even nicer, x to the power of 1 over root x. Sorry, tripped over my words. But that's the idea. You just think, instead of timesing by the power, decreasing the power, you increase the power, divide by the power. Okay, we'll do more examples, but that's the idea.